Oh yes. First one I asked you to do is convert. Let me just open them up here as well. Mhm. So yes, the first one was convert into joules.
1.5 nanojoule into electron volt.
Okay, that should be easy peasy. 1.5 nanojoules into electron volts. Okay. Nanojoules, that equals 1.5 times 10 to the minus 9 joules. So what you need to do is, well, you can use your calculator here in fact, but well, let me just write down on the side here. I just need the number. You just recall on the side for a moment that 1 electron volt equals 1.6 times 10 to the minus 19 joules. So if we go back here, I can do 1.5 times 10 to the minus 9, and then if I, sorry, what I mean to do is put a 1.6 times 10 to the minus 19 here, and a 1.6 times 10 to the minus 19 here, joules. And if you look, this here is 1 electron volt. So I get as an answer 9.36 giga electron volt. Okay. Yeah. So number 2 is 2.5 electron volts into joules, which is actually much easier. Maybe I'll swap them around next time. Sorry, do you have this? Yeah. So 2.5 electron volts equals 2.5 times 1.6 times 10 to the minus 19 joules, which is 4 times 10 to the minus 19 joules. Got that? Yeah? Guys, okay. What is the potential energy of a proton which is equal distance between two parallel plates separated a distance of 1 millimeter with a potential difference of 9 volts? Okay. So what you have here is plate, plate, 9-volt battery, and the distance of 1 millimeter. And in fact, it doesn't matter which one you say is the positive and which is the negative, because the proton is exactly in the middle anyways. So I think maybe to make it a little bit nicer, I'd like the proton to be pulled down. So yeah, I have this the right way around. This is negative and this is positive, and the proton height is half a millimeter. So the formula for potential energy, not mgh, but QEH. Ah no, I said I haven't decided which I prefer. Now the E is V over D. So we know the voltage, it's 9. We know the D. Now this D is the total 1 millimeter, and we know the H is half a millimeter. So it'll be 4.5 times whatever the charge of a proton is, because it's 9 times a half, because it's a half a millimeter over 1 millimeter, which is a half, regardless of the units. So it's 4.5 times the charge of a proton. Now the charge of a proton is, you get the same answer. Half a millimeter over a millimeter is still a half. Even if it's converted into meters, centimeters, inches, feet, miles, light years, half of the unit of measurement over the unit of measurement is a half. The units cancel. Right? We're cool? We're cool. Okay, so what did I say the charge of a proton was? Where is it here? It is here. Times 4.5. 7.2 times 10 to the minus 19. And I didn't ask you to, joules. I didn't ask you to do this in the question, but I think I kind of like it as well. What is the answer in electron volts? So the answer in electron volts is 4.5 electron volts. Okay, is that okay? So the next one, how fast would an electron be travelling if it leaves a negative plate and strikes a positive plate, which is 2 centimeters away, and the distance travelled has a potential difference of 12 volts? We don't? Yeah. So what did I say leaves the plate? A proton? Not that it matters. So you have your positive, you have your negative, and the proton is here, and then it flies down and hits this plate. The distance is, well, the voltage is 12 volts, and the distance is 2 centimeters, and it is a proton. So, what you have is up the top, it has potential energy. Only potential energy is at rest, really, when it leaves the plate, or at least is nearly at rest. It will accelerate from the field, and then it will hit the plate down below. It will have kinetic energy. So it's just like in mechanics, the potential energy at the top equals the kinetic energy at the bottom. So you have M, E, not M, what am I saying, sorry, Q, E, H equals a half V squared. So that means V equals 2QEH, 2QEH over M square root. So if I type, oh yeah, and we don't know what the E is, but we have a formula for the E, which is V over D, so it's 2QVH over D. E is V over D. But the D and the H are the same here. They're both 2 centimeters, so that cancels that. So it's square root 2QV over M, which equals, okay, so square root fraction 2 times charge of a proton times the voltage. Oh yeah, sorry. Maybe to make it a bit different, I'll put little ticks here or something to make that clear. That's a voltage. So yeah, that's voltage there. Times 12 over the mass of a proton. So we get 47947 meters per second. We're good? It's a lot like mechanics questions, really. Yeah? Can I go to the next one? Yeah. Okay. How long would it take for a proton to travel from a positive plate to a negative plate if the distance between the plates were 1 millimeter and the voltage of the cell connected to the plates was 25 volts? So it's 25 volts and a millimeter, and it's a proton. What number is this? 5. So you got your positive, you got your negative. Sorry, I got to think of something else. We got our positive or negative, 25 volts, and a distance of a millimeter.
1 meter.
And we'd like to know how long would it take to go from here to here. So if you want to do this using the potential energy formula, what you could do is just like with the last question, we can say potential equals kinetic, and basically I'll go straight to the same thing at the end, which is we can get this formula for the velocity, root 2qv over m. So when the proton makes it down here, it's starting at rest, and its velocity down here is root 2qv over m. Now what you'll notice that's quite interesting here is that the distance isn't in the formula. What's the only thing that's different in this formula?
Distance cancels out.
Yeah, so what's the only thing that's different in this formula?
The M.
No, it's still a proton.
The cancel that?
Voltage.
The voltage is the only thing that's different in this
The
formula.
last one, yeah.
So this time we get a V of 69206 meters per second. Now we do need to use the S though, because the next part we have U V A T S. U is 0, V is 69206. The A we don't know, the T is what we want, and the S is 1 millimeter. So that's 001. I think I'll use S equals UT plus a half AT squared because the U is 0. So I get 0.001. No, I shouldn't because I don't know the A. V squared. V squared equals U squared plus 2AS. U what am I down to? V equals U plus AT. There's only one formula left. S equals U plus V over 2 times T. S equals U plus V over 2 times T. Now we barely ever get to use this formula. So the U is 0. So the T would be 2S over V, which would be, okay, 2 times S divided by V. So when I put in the numbers, I get a tiny value, but I should get a tiny value. It's going so fast and it's such a small distance. 28.9 nanoseconds.
Why did you put 25 instead of 6 times 26?
25? Where's 25?
In this formula, because you wrote over the v6 line to this 6.
Yeah, that's the velocity.
Which
Velocity. This is
I know, but
the voltage.
why the you divided by 0.
Huh? These
Why
are
is 25?
these are velocities. And
So that's 2s?
where's 2s? Oh, this!
Yeah.
That's a 2s, yeah. 2s. It's coming from this line. Yeah. Yeah. Okay. Number 6. 6, yeah. Um, 6 is an exam question. Even though it's a little difficult, it's still an exam question. Let me just load something here. Okay. I want to make this one the first one. Right. So you have a battery, it's connected to two horizontal and parallel plates. One plate becomes positive and one plate becomes negative. I should say an electron is fired at 45 above the negative plate, which lies flat on the ground, into a field under the positive plate. The distance between the plates is 10 centimeters. The electron just about misses the negative plate above it. The electron then falls down to the positive plate. What is the EMF? Right, so it might seem difficult, but it's not actually that difficult. I mean, there's nothing new in it. We've seen stuff like this in different parts of the course. So what's happening here is, well, firstly, let's get the information. It is 10 centimeters. We don't know the voltage. And this is positive. This is negative. We don't know the voltage, but we know that the distance is 10 centimeters. We also know that the proton is fired at 45 degrees, just about misses the top plate, and then comes crashing down like that. So, because that's 45, and we'll actually, did I tell you what its speed was? No, rats. Do I need to tell you its speed? Probably. I'll just call it speed u for the moment. So this side here is u cos 45, u sine 45. Okay. So there's a couple of ways to think about this, but maybe the easiest way to think about it would be to do with energy. That the kinetic energy it has here at the beginning must equal the potential energy it has here up at the top. But you can also think of it as like a projectile problem. The only difference is, as the proton is moving, it's not mg that's pulling it down, but what force?
Q.
QE. This takes the place of mg. Okay, so let's work out the time to get to the top. So you have, if I look at the y, u, v, a, t, s, the u is, yeah, no, it's a different u to that. U sine 45. What's the v at the top? 0. The a, don't know. The t, don't know. And the s, 10. Now actually we kind of do know the a because we can use Newton's law here. F equals ma, and this is the f, isn't it? So that equals ma. So you could say that the a is QE over m. So since it's a proton, you know the Q and the m. Sorry, it's an electron, you know the Q and the m. So this a is QE over m. You know the v is 0. Oh no, but that's what we're looking for. So we have this information here. Okay, let's see what we can make if I use these three. V equals s v squared equals u squared. V equals u plus at. S. I'm trying to think which formula. S equals ut. No, v equals u plus at. V squared equals u squared plus 2as. I wanted to avoid using u, but I guess I can't. V equals u plus a t. So I can get the t here. It will be minus u sine 45 times m over qe. What? This is v equals u plus at. Yeah? Now, the negative's actually okay because the charge is negative, so they cancel the signs. The time will still be positive. Now, you know that the distance it travels must be 0.10. So you can now say S equals u t plus a half a t squared. And that a, well, that a is actually, that's going down. I've got to be careful with my signs. Yeah, and the q is negative, so it is going down. S equals ut plus a half a t squared. Oh my goodness. U squared sine squared 45, yeah, m squared over q squared e squared.
More easy if you just get the speed.
Oh well, I mean, it's still going to look like this, but just a number. I haven't put any of the numbers in yet. None of the numbers have been put in. So let's look at what numbers we know and what we don't know. So, okay, we know the distance here. I could give you the u, so that will be okay. The sine 45 we know, the m we know, the q we know, the e we don't know. The half we know, the q we know, the e we know, the m we know, the u we know, that we know, that we know, that we know, and that we don't know. I'm going to make up a u, because I didn't give it to you in the question. So we'll say here that u equals 1,000 meters per second. So I better fix that. kilometer per second. Okay. So now we need to put in our numbers. Okay, so first one. 1000 sine 45. 1000 sine 45. 1000 times sine 45 times 1000 times sine 45 times the mass of an electron, which is constant number 3, divided by the charge of an electron, which is constant number 23. So when you put all those numbers in, you'll get here 2.84 times 10 to the minus 6 all over E. Plus, and now we'll do the other one, and there'll be an E squared down below that we don't know. But we'll put in all the other numbers. Okay, fraction, a half, times fraction, on the top, Q. Oh, now look here, that E cancels with that, so I actually can get rid of that power there, which is nice. Okay, E over M and then still on the top times 1000 squared times sine 45 squared times the mass squared all over mass times charge squared, which is 23. Right, let's see what I get here. Yeah, great. 1.42 times 10 to the minus 6. So what I'm going to do, well, I can add them together. So 1.42 plus 2.84. So I'll get 0.10 equals 4.26 times 10 to the minus 6 over E. So now I have E equals 4.26 times 10 to the minus 5. Now that's not even finished because I'm looking for the voltage, but you know that E is voltage over D. And what did I say the distance was? 10 centimeters. So it's a pretty small voltage. 4.26 nanovolts. I've seen this question like this in the exam before because it mixes projectiles in two. So it mixes two topics. Yeah? Okay. Yeah. Just want to check one thing here. I just feel like I should be adding something else into this question. make it a little bit more difficult. Yeah, serious, just a tad. Um, what could I add in? Maybe it's difficult enough. Any extra things? No, no. I think that's pretty difficult. Although I do remember in the exam they did have something a little extra that they just kicked into you at the end. Can't remember what. So anyways, this will be like an exam question, but at least it's part of the section B question. Okay, so I mean, the other questions were more like section A questions, like 1 to 5, section A question. Um, I could ask you something like, kinetic energy at the start, but that's lame. It's not difficult. No. Can't think of anything else to make it more difficult, so we'll just leave that one there. Okay, let's close that. Actually, while I'm here, let me just stop this for